Very, very important point to start is A, we are not selling anything. We have no commercial interest in any of this stuff at all. We've had people ask, like, because we did this presentation at the Arcadia bus rally, people come to us and say, so did you sell any there? And I'm like, no, we're just sharing the project we did on our bus. We have no angle on this. We're not selling anything. We just like to give back to the bus community. And B, well, in Arcadia, they asked us a long time in advance, or we volunteered. Here we found out they want us to present
last night at dinner.
So we're kind of pinch hitting here. This is actually the same presentation from Arcadia where it was saying preliminary report, and we've now had a year's worth of time on the batteries.
It has been 1 year to the week since we installed the battery bank.
And so yeah, we're in a case because there's no topic was announced. Our topic, if you haven't figured it out, is our lithium-ion battery bank. There's very few people who've done a battery system like this in an RV of any sort. It's happening more and more in the marine space, but it's still very, very new. We are on the cutting, bleeding edge. The reason we're on the cutting, bleeding edge is when we bought our coach a year ago, it had no house battery system, no inverter. Not much on the way of a good electrical system. So we were starting from scratch, and we like geeky technology, and we figured why not start at the very bleeding edge of it all. So this is kind of sharing our research into why lithium versus lead and what it's been like using it.
Right. Maybe we should start off with what our goal is with our bus. We're full-timers, obviously, if you haven't heard that yet. We've been on the road for 6 years now, 1 year in the bus. And we want to create this bus to be very versatile for going either pole to pole or doing a lot of boondocking. So we like the variety of going into a city or also being off grid. And we wanted to design the bus to be very versatile for that. We do eventually plan to do solar panels on the roof so that we have sort of more energy independence. And we also wanted something. We've got our cat. You've probably seen her on her leash walking around with us. She likes air conditioning when it's hot. So we don't want to ever have to feel like we can't make a stop somewhere, maybe go for a hike or go do some shopping or something like that. And we wanted to be able to run the air conditioner off of battery power without having to run the generator in a parking lot for about 3 or 4 hours at a time. So that was our goal in designing this lithium-ion battery bank system.
So feel free to throw in questions at any point in time. This is pretty informal, and we're just going to talk through batteries, first off starting with the traditional lead-acid batteries. That style of battery, lead-acid batteries, in one of the blog posts I actually have the date, but that chemistry of battery has been around since the 1700s and is in essentially every vehicle. I guess this is one way to see the slides. We'll have to post the slides separately.
Yes, we'll post the slide presentation online later.
The battery chemistries haven't changed much. The newer AGM and gel cell batteries are still lead-acid batteries, just with some sort of material to keep the fluid from spilling out, the battery acid from spilling out, either a gel or a glass mat. But it's still basically exactly the same type of battery. There's always been other kinds of batteries. NiCads have been around for a long time, but lithium is a completely new, different type of chemistry. It's different material. It's not lead. It's a lithium, a different metal that it's made out of. Different internal chemistry. Was for quite a while, most of what was considered lithium batteries were lithium cobalt oxide. It was a lithium cobalt mix, which is really great for a lot of small electronics. You didn't want to make it too big because if something went wrong charging it, it would catch fire.
Right. So a lot of people, when we first started talking about doing lithium, they said, "Oh, you don't want to do that. Your bus is going to catch on fire." That's the kind of lithium battery that the airlines don't let you take on board, that you heard about laptops catching on fire, mobile scooters.
A lot of RC cars, that's where most people had the fires because they had homebrew chargers and stuff. They get their lithium battery bank, they leave the charger on too long, and next thing they know, their shop is on fire. That kind of lithium, lithium is a metal that burns very, very hot and very, very fast, and you don't want that to happen to your coach.
So this is not the same lithium technologies. It's not the same chemistry that you heard about in the news probably about 10 years ago about fires happening from lithium. So this is a different chemistry.
So the newer chemistry, the kind of the big breakthrough in making lithium safe for larger vehicles and larger applications was called lithium iron phosphate. You'll see it either written out as LiFePO4 or LFP. So people talk about LFP batteries. The lithium iron phosphate has slightly less energy density than the lithium cobalt, but you could set it on fire. You could try to set it on fire. You could shoot a bullet into it. You can do all sorts of things. And just like a lead-acid battery, it will be bad. There might be a short circuit and stuff, but the battery itself will not burn. So that makes it actually practically, worth putting underneath your house, safe in that fashion. One of the fundamental ways that when you're thinking about a lithium system is if you've all looked at your 12-volt lead batteries, they've got 6 little watering spots on the top, or 6 cells inside of them. To get a 12-volt equivalent lithium battery, it's actually would be 4 cells. There's the chemistry generates different voltages per cell. So that's kind of one of the primary differences. So why replace lead acid? It's been working really great for hundreds of years. It's solid, reliable. We all know how it works. If you take care of your batteries, they serve you very, very well. There are a couple key downsides. The biggest one that hopefully everybody who's got a coach knows is if you've got a 500 amp hour less battery fraction of its capacity to get the battery back and topped off, which you think, oh well, I'll just stop then. Who needs that extra 20%? Well, A, that you want to use that because you actually want to have that high. Use the top 20% is when you're aging the battery least. And B, lead-acid batteries, if you don't get them to 100% charge fairly regularly, that also ages them prematurely. The batteries are very, very happy when they get a regular full charge.
So that means if you're running your generator, and it's also a very slow charge,
right,
that last 20%. So if you're running your generator, you're having to run it a lot longer for that last 20% to get that top off. Or if you're on solar, you've got a lot of situations.
The sun will set before you get the top.
Right, because it's a very slow charge for that last 20%. They cannot take it at a bulk charge rate.
So a lot of batteries in solar systems, you either have to over-engineer the solar system to make sure your batteries get to a top-off charge early in the day, or your batteries actually age really prematurely in a solar installation if you don't find a way to plug into a pole or something else to give them a full top-off. Finally, lead acids, AGMs are much better than this, but typical flooded lead acids use about 15% of the power you put into them just turns into heat. So if you're charging off the solar in particular, or if you're paying at the meter, perhaps, that's power you're just wasting. If you're trying to be really energy efficient, you don't want to throw away 15% of your charging power as heat. Two of the final things is, I'll explain this a little bit more later, there's this thing called a Puchert's loss, that if you're actually taking a lot of current out of a battery, like running a microwave or an air conditioner, a lead-acid battery has a very high Puchert's loss, which means the capacity of the battery is diminished if you're drawing a lot of current. The batteries are rated for drawing them, for using the power in them over 20 hours. If you use the power faster than that, I'll show you a chart. Lead-acid batteries, the capacity actually drops a lot from what you think you have.
So here you've got a 500 amp hour AGM bank. 250 of that is considered usable under normal load conditions.
But if you try to run your air conditioner, you might.
It's going to take a lot of that capacity right out of the bank just by having that really high draw all at once. So you're losing a lot of your capacity when you're storing in lead acid.
And then finally, the most obvious issue with lead acid batteries is they're really, really big and heavy. If you ever tried to move an 8D cell around, it's a hernia waiting to happen. So that's the downside of lead acid. They're great, they're reliable, they work well, they're cheap. There's a lot of upsides to lead acids. But now here's the upsides to lithium. It basically kind of answers all those issues. The one biggest one is with a lithium battery, it doesn't really suffer much to use its usable capacity. So if you've got a 500 amp hour bank, you have really 500 amp hours. You don't have to stress about not going below 50%. Or not going below 20%. You can use your capacity there. The cells are still so new that there's not actually a lot of in the field evidence of long lifetimes. But in the lab, lithium cells, our cells were cycled to 100% from 100 to 0 2,000 times, and we're still able to maintain a full charge. So the batteries will last through a lot more use than...
They're saying 5,000 cycles is actually a predicted. Now, the key word is predicted. Yeah. You have to remember lithium...
The cells aren't long enough to have lasted...
Yeah, there's no one who has used these long enough, except for in electric vehicle modes, to actually have tested this to see how well they're going to perform. So that's the big risk with going lithium.
And then one of the best things is if you're charging, particularly off a generator or solar or any way you want to try and charge quickly, the lithium batteries don't have that absorption phase. You can bulk charge them all the way up to 100%. So you don't have that lingering slow time of topping them off. And if your charger is powerful enough, if you have a really huge alternator or you have some really crazy battery charging system, lithium batteries can take huge charge currents. So theoretically, our battery bank, I believe, is rated to C3, which means you could charge it in a third of an hour, so 20 minutes. You could
charge the entire bank.
If you have a charger big enough, the batteries would not be roasted and boiled charging at that rate.
So it's really cool is if we like boondock overnight, like we'll sometimes just stay overnight in a Walmart or something like that as we're passing through and making miles. We'll get in, we'll get some work done online. We have 2 of these monitors inside that we're running off the battery bank overnight. We might run the fan, we might cook dinner on our induction cooktop stove. And then, okay, so we get the batteries down to about 60%, maybe 50% overnight. We just drive 2 hours the next day. They're charged up. They're ready to go. They're up to 100%. We're ready to go another day.
Our alternator puts out about 220 amps. If we had something that could put out 400 amps, our batteries would be very happy to take it. If we had something that could put out 1,000 amps, I need really big battery cables need really big cables to deal with that. But the battery can handle it. And then there's no downside if you don't top off the battery. With lead acid, you want to get it up to 100%
every so often,
at least once a month, because your batteries are going to start to suffer otherwise. Lead acid, if you're on a solar installation or you just aren't plugging into a pole lever, the batteries don't care if you're bouncing them between 40% and 80%, or
you'll take whatever you can
30%.
give it. So if you got quiet hours at a campground with your generator, they say they want your generator off by 9 p.m. and your batteries are only gotten up to 80%. No big deal. You're not harming your batteries by doing that.
Then, so regularly charging has no downside. There's very little power is wasted as heat. There's such low internal resistance. There's not a lot of heat generated from charging them. So the power from the sun or from wherever goes actually into the battery, so you can get it back again. The Puchert's loss, when you put on a high current load like an air conditioner or microwave, the battery doesn't lose capacity under high currents. And then small and light. So that little bank in there is 500 amp hours of power. In a fraction of the size and weight of 8D cells would be, or traditional bus cells. That weighs 140 or 160 pounds.
Not a lot. Yeah, right. Same basic.
Are you running 12 or 24? Refresh my memory.
We're running 12.
Our coach is a 12-volt coach. Wish it was 24 because I could get by with smaller cables and a bigger inverter.
But you can hook them up anyway. The cool thing about lithium is you build them. We built this bank ourselves. We just bought the cells. And you can build it any way you want, any size you want it to be.
So this is probably going to be pretty hard to see for anybody who's not up close, but this is just a quick visual. I'll try to illustrate it here of the charging current of lead acid. You got your charge current and your charge voltage, and you get to the bulk point, and the current just drops. That's the absorption phase, and so as you get closer to 100%, you're actually charging slower and slower and slower. The slightly different graph I was able to grab for the lithium, but it doesn't have that drop off. It actually just stays nice and flat until you're all the way at 100%. So fast charging is great. This is where you can see the Puchert's loss. I'll start over here with the lead acid batteries. Lead acid batteries are traditionally rated at a 20-hour rate, so they've got 100 amps. They can deliver, if they have 100 amp hours, they can deliver that power. You'll actually get 100 amp hours if you draw it out over 20 hours. So it's a 20-hour rate. That gives you 100% capacity. If you're drawing it such that you're like running something high current, like that will draw that entire battery down in an hour, like you're running your microwave or your air conditioner or something like that, at the 1 hour rate, a lead acid battery has a 60% of your capacity. You'll only get 60% of your capacity if you're running your battery under very high current. Something more typical, like hopefully your system can last more than 1 hour under your microwave, but actually maybe not. But like the 4 hour rate, this is a lifeline batteries would be give you 80% of your capacity. So you're throwing away 20% of your capacity if you're using something really high current. Lithium batteries aren't rated by 20-hour rates. They're actually rated by C factors of how many fractions of an hour you're going to drain it. So the lithium battery at 1C that's the red line here is actually half a C, is going to draw your battery down in 2 hours. This is over 100%. 1C is almost identical. 2C, which means you're going to draw your battery down in half an hour, is still over 100%. Our batteries were rated at 3C, so you'll get your full capacity if you're drawing your entire battery down in 20 minutes. Because lithium batteries, for the most part, were designed and marketed for electric vehicle applications, where you're drawing the battery up and down, up and down, up and down. So they're... Yeah.
There's actually, I talked to someone just this week, and he just installed a C13, I think.
C12.
C12 or 13 that's come out.
Theoretically, be able to drain your entire battery in 5 minutes.
Yeah.
Hopefully, you never design an RV house.
Yeah,
Like
if you're running that sort of stuff in your RV, I really want to know what cool stuff you're up to.
Yeah, right, laser. Brain surgery.
Here's Lifeline is one of the best brands of AGM batteries. That's what we had done in our prior trailers. Here's their expected cycle life. So if you never cycle your batteries below 10%, you'll get 5,000 cycles out of a Lifeline battery, which means that if you're basically going pole to pole and using very little in between it, those batteries will last a long, long time. But if you are not
using your batteries, and you can nurse them and keep them healthy, and
but if you start to get to the point of, oh, I've taken my batteries down 80%, if you don't actually have a real battery monitoring system, you're probably doing this by accident all the time. Well, 80% gets you down to 500 cycles before the batteries are essentially considered dead.
And some people actually, they budget that in. They'll go and they'll buy the batteries and they just budget. I'm not going to worry about it. It's just part of my energy use budget,
Before you get too much further, just most of us have Lifelines or AGMs, and I'd be interested in your take on from fully charged, and the way we use these coaches. Are we better off to try to keep them peaked? Are we better off to really run them down? Or in the middle?
It depends.
How do we maximize our
keep
life?
them peaked. Lifeline loves to be, AGMs love to be kept peaked as possible.
But we know people that they just intentionally, because they're running mostly off grid, like Sean and Louise of our Odyssey. I'm sure you're familiar with Sean Welsh. He actually budgets to plan in with his AGM bank that because they're running off generator most of the time, they just decided not to spend the extra fuel to run their generator to get from that 80 to 100%, and they just run theirs between 30 and 80% is what they consider, and they know that they're going to age their batteries faster that way, but they did the calculations for them that it would cost them more in diesel fuel to be trying to peak them, and every so often they'll go and they'll peak them up to 100%. They'll spend the money, or if they get a 50 amp plug-in or something, they'll peak them up, but they've just budgeted in to run them between 30 and 80%, and not running that extra generator time to keep them peaked.
Yeah, so the batteries are happier being peaked, but your diesel budget might not if you're charging them off of generator.
I just replaced mine. I had 10 years and 4 months on them.
Awesome.
That's full time, mostly off grid.
Awesome. What kind of batteries were they?
Lifelines.
Lifeline?
I run 6 ATMs on there.
Sweet. And do you use a battery monitor and have like a strong cutoff point of how low you take them?
I try not to get below 40%.
Cool. Awesome.
Generators are normally set to kick in at what percent of the life capacity of a battery?
Generator auto starts vary quite a bit, and in particular, I think most of them are triggered by a voltage level. And voltage level is usually a pretty poor indicator of the state of the battery, because that doesn't. If the battery is under load, the voltage where it's at will be different if it's under various loads. Using a real battery monitor system and something smarter to trigger the generator that calculates the current in and out of the battery and gives you a real percentage reading. If your battery's at 85, 90, 20, and then starts the generator, it's probably better. I have not done too much research into generator auto starts, though, because our generator won't support one.
Well, it's a setting through the Trace or Magnum or whatever you have.
Yeah, so it's got a trigger out.
Which is adjustable.
It is a voltage issue, and you can correlate it, not perfectly, but to the percentage of the battery.
But you don't want it auto starting. If you set it up too high, where you just are down 10 or 20%, the thing's going to run, shut off.
Right.
So it's how low you want it to go.
The weight to power ratio with these new batteries.
How much does yours weigh?
140 pounds. 40 pounds.
140 pounds for 500 amp hours.
And an 8D weighs 120 maybe?
I think we have a chart later in the presentation that shows the comparisons.
That's in this one.
Yeah, all
Yeah.
those are about one.
You used to be able to carry one, but I just figured I was
Yeah.
old and weak.
So yeah, the other advantage is a lot more power and less space. If you've got a big charger, you can design a system to quickly charge the batteries, or you can design a system around having high current loads. So not a lot of people have their coach set up to run their air conditioners off their batteries because it requires hefty inverter, and there's a lot of other traditional downsides. But that's one of our main goals, is we wanted to be able to run the air conditioner off of stored electrons. Now the big go ahead.
My question was to replace 6 8Ds. We know the weight of them are 165 pounds each.
Right.
What kind of poundage would be with the lithium?
What's your amp hours? I don't know what the amp hours are.
D6 is about 500.
So this is 140 pounds. So there's your difference.
So it's about
So that'd be so that'd be 1,000 at 12, and depending on how much of that capacity you want, you probably 200 pounds.
Oh, less than that. Well, because so your capacity is 500 amp hours.
I'm not sure.
Okay.
Technically, but there's 6 8Ds.
Okay.
So
yeah, I mean the amperage varies by manufacturer and stuff like that, so it's not a hard and fast
It's
8D
a
equals.
lifeline battery.
right.
Okay.
I have all the charts actually.
Yeah.
I wrote a couple articles I put on the website that did more of like here's we actually was using Lifeline AGMs as a comparison. Here's a bank with Lifeline. Here's a bank with Lithium. And here's the weight, and here's the size. And here's
Right.
the
You also have
cost.
to consider though with your AGMs, you're not getting. I mean, what percentage do you take your batteries down to? What are you comfortable with?
Unfortunately, that's the voltage factor.
Right.
And
Right. So if you're aiming for 50%, then consider that the lithiums you can get half the capacity
And
as
use
well.
power.
So you don't have to match amperage to amperage to get the same
Right.
sort of power out of it. You can actually reduce your bank. So you're also reducing a lot of the weight
So
there.
the only difference between a Lifeline and a conventional lead acid versus a gel is the amount of time you can draw down.
The main difference with Lifeline is they're very high quality batteries. There's at some level there's not a whole lot of difference between various lead acid batteries other than the quality put into them, how robust they are, how
The
well
fittings that they
are.
use, the construction,
the internal
Where
construction
yeah.
in
does that
particular.
translate to efficiencies?
A good battery, a Lifeline battery, could take a lot more abuse. Is the main thing it comes down to, and yeah, there's very little difference in capacity. A given volume of lead acid has a certain amount of power. They might, just by the shapes of their cases and how big their plates are and stuff, they have a very slight variation between any given makers around how much power is in them. It's just mostly the quality and also the quality of the support and the warranty and stuff. So a company like Lifeline will stand behind their batteries, whereas a company like random no name will not. But
or may
then,
not.
But then if you buy them from places like Walmart or Costco that have very generous warranties, they don't care if you destroyed the battery. They just take it right back and give you brand new ones. And we've met people who that's their battery plan is they abuse their batteries. They never
For a year, they
pay
just
attention to any of taking care of them at all. The batteries toast after a year. They take it back to Walmart. Say it doesn't work. Get the brand new one. Keep repeating. And that's cost effective, but I don't like that style.
The Lifeline does have two features that are unlike some of the brands. The plates are thicker. And what it's doing is just denigrated the plates it's used through every cycle. The other thing they do is their distance from the bottom of the plate to the bottom of the tank it sits in is greater. So when those inferior products drop into that space, it doesn't short out as quick as a traditional battery. Those are the two that I
know. The quality of the build that goes into the higher end batteries makes a significant difference.
I was told, and I'm not sure how professional this is, but that if you put a high charge on a lead acid battery, you clean it up a little bit, you burn off some of the.
The equalization?
Well, there's the equalization charge that.
No, that's just a heavy charge. Put a real heavy charge on it.
Yeah, that's the equalization charge. I think is what you're referring to.
In general rule of thumb, the number one reason batteries die is
Right.
how you charge a battery.
And actually,
A lot to do with
where equalization matters more is for like if you have a battery installation for a house, like a solar-powered house or something, because that does basically boil the batteries, it sort of cleans them out, you could say. But in a coach that moves, you get that kind of benefit for free, and so that the stress of doing that overcharge doesn't really necessarily buy you much if you're actually driving around. Solar chargers designed for house installations always have, well, once a month we'll equalize the batteries, because the batteries, unless you're in earthquake country and it's a really bad time of year or something, your batteries aren't getting shaken around. So equalization probably is not something that matters too much for coaches.
Gel, you don't want to do a gel.
And period, you never want to equalize a gel cell because, the gels, it's like a gelatin. The battery is full of gelatin, and when you equalize, it makes the gaseous bubbles. Well, those bubbles are in a gelatin will never go away. They have no way to go anywhere, so you can destroy a battery if you try and equalize a gel. Flooded leads, it's actually a good thing. You'll bubble off some of the water. You put in some more distilled water. The battery is happier and healthier. AGMs are more tolerant, but not, you can't put more water in an AGM, so you need to be more cautious than with a flooded cell where, I boiled it, okay, more water.
Does that mean you need to charge an AGM slower than you do a lead acid?
No, actually AGMs can charge faster than lead acid because they have lower internal resistance, but you need to be very careful not to overcharge them. You don't want to take the voltage over the target level.
I believe Fred is presenting on batteries in general this afternoon. Is that correct?
A little bit.
Okay, so if we can save the lead acid questions.
They've got here, but I've got a little bit on that.
Yeah, I think these questions are probably better for this afternoon. So if we can get back to lithium.
Okay. Cool.
What about cost on your lithium?
That's the next slide. That's the next slide.
That's what's on the screen.
Yeah. So the catch with lithium. Lithium is on paper pretty much the perfect batteries. 10 years from now, it'll probably be everywhere the replacement for lead acid. It's got too many fundamental advantages. The downside right now is it's new. Lithium costs more than lead.
And also charge controllers. I got a question on here. Can you use the same charge controllers?
Yeah, and potentially, every old battery charger's got a little flip switch for flooded AGM gel. None of them have a little switch that says lithium either. So unless you've got a programmable charge controller, you might have to change out how you're charging your batteries. All this, so the cost becomes the downside.
Well, what about charging it off your alternator when you're running?
You still need a charger.
Well, no. So two things is the battery monitor system, and I'll talk about that in a second, can cut off the batteries fully, basically disconnect them if the charge gets too high or too low on any given cell. So if I'm charging up the alternator and the alternator starts to run away or starts to put out too high of a voltage, the battery disconnects itself. It says, I'm full and I'm getting close to being overcharged. It pulls its own plug. And the same with on the low side, if something is putting a load on the batteries and the inverter forgets to turn itself off, or there's a fan running too long, if the battery, any of the cells say, I'm getting critically low, it'll pull the plug and basically disconnect the battery.
Has it got a regulator in there, or that actually does that itself?
It's I'll let you stick your head in here. It's a battery management system that monitors the voltage across each cell and then has two big contactors that it can trigger to disconnect the battery. And that's separate electronics. In our system, we wired it and designed it all up ourselves, so there's people who are going to be selling batteries that have that all built into the battery box. Lead acid would benefit from the same sort of thing, but because lithium's cost more, people are willing to invest more in protecting the battery from a bad charge situation or an over discharge situation. Lithium, if you boil your expensive batteries, well, you'll be very, very sad. And if you drain them and they won't take a charge again, you'll be very, very sad. So the catch of lithium is the cost of both the stuff around it and the cost of the cells. So Cost of the cells, our bank, list price for 500 amp hours was
$3,100.
$3,100. I think what I worked out, the same capacity of AGM, the lifelines, was going to be $1,800.
Yeah, because we looked at because we wanted to go for 400 usable amp hours to start our bank with, and we figured if we safely set 20% as our low point on the lithium bank, 500 amp hours would be a good number of capacity. To do that with AGM, we would have had to go with we would have had to go into an 800 amp hour system. So that's what we were comparing, both weight, cost.
Over 24 volts.
Yeah, I'm talking 12.
12 volts.
Okay.
But 4 batteries. What the hell's 12? They're right at 400. Oh no, it's higher than that.
650 for an 8D.
Shells are even more. They could 700 piece. So
Yeah.
Let me make a couple of comments.
Okay.
Maybe you go in there.
Yeah.
A lot of cars now are using AGM batteries under the back seat that are quote not serviceable by the user. And I guess Toyota has announced that they are going lithium ion in what 13 or 14. In my opinion, is that this whole thing is going to get a hell of a lot cheaper.
Oh yeah. It's already getting cheaper just because of the EV market.
Yeah, you need to go out and price some AGM batteries right now because it's changed dramatically.
It's about 675 for an 8D.
Our pricing was
when was that?
Yeah. So our pricing we took from a year ago when we were doing our comparison.
Okay.
But we took kind of
Wow.
So we kind of looked at what the high end for Lifeline versus what some of the more off brands were, and we just took a median number because we didn't want to skew it too much.
I know, but the difference between $2,800 for the sake of
Oh, yeah.
and
That's
$3,500 is phenomenal.
Yeah, that's the math we came down to. Is for us, since we were starting from scratch, it was only like $1,000 more for us to go lithium, not including the. The inverter. Well, we didn't have an inverter anyway, so we're going to be buying one. And we like to play with stuff, so we'll be going over that.
It's a Victron, and I'll get to that in a second. So yeah,
While you're on the cost, just trying to conjure up my thinking, knowing the information everyone just gave me, if I could get at least 10 years out of what you sat in that cabinet, I'm good.
Yeah, that was the other cost factor we came to.
And I think you're going to get 20. Depending upon how
Right.
That's when you start to do the math on lithium. The lifetime cost comes out way ahead.
If you're going to actually be using them and cycling them that much, we actually came out. Our best guess for math was anywhere from it was going to be either 1/3 the cost, considering that we would be replacing an AGM bank continuously, or it would be about even if you didn't factor that in. If we could actually do what you did and actually keep a bank healthy for 10 years. But so our math was it's actually cheaper long term for us to go lithium than it was AGM.
So yeah, our bank was $3,100. There's right now companies that are marketing lithium to the marine industry, where people tend to have yacht budgets and are a lot less cost constrained, and they're selling them with service and support and packaged up all in fancy, just drop it in your yacht type things. And so they have the yacht prices attached. But even at the yacht prices, they're able to demonstrate that over the life of your boat, those things will pay off versus traditional AGMs, or will be break even. So if you're willing to live on the bleeding edge and build your own like we did, we got ours for a fraction of half of what we would have if we'd gone to one of the yacht marine battery suppliers. But we actually built our own cells, or built our own bank out of cells. So here was some of our math from last year, comparing AGMs, an 800 amp hour bank of AGMs versus a 500 amp hour bank of the LFP batteries. Our list price was $3,100. The list price I was finding, actually that was the average retail price.
That was the average retail price. That wasn't even going Lifeline.
Last year, AGM was $1,840.
Would that be a Lifeline?
No, this was just an average cost. We looked at several battery manufacturers.
Lifeline was right around that, though, because Lifeline was the benchmark I was going by, but I didn't skew it just to Lifeline. I looked at a couple other batteries, too. The weight was 535 pounds versus 140.
Usable amp hours are both 400. cycles, we did 2,000 versus 500. So we went on the load side of both, just to give. We wanted to compare as much as we could, apples to apples. But we came out with per cycle, doing a full first was $1.55 per cycle with the LFP versus $3.68 for the AGM.
So over time, it looks good. Here is actually a slide I found from Genasun, which is one of the companies that are selling full systems for marine. And their battery bank this is small, so it's to show it, but their battery bank for 360 amp hour bank was $7,700. And they're comparing versus Lifeline specifically, and they're saying they're working it out that it's basically break even over lifetime, even at that price.
You said you've had that bank for a year?
1 year.
1 year.
The cost then, the cost now.
It's the same cost right now.
The battery price hasn't changed.
They have not changed. I just checked this morning. The prices have not changed from our supplier. We are talking with more and more people that are getting them from other electric vehicle suppliers, and they're finding other slightly different battery chemistries, and we're getting prices. They're all in the same range, but people are finding them cheaper, more expensive. I mean, they're all over. The company we went with, that we just happened to be in Arizona at the time, and they were excited about what we were doing. We're their first motorhome RV application that they had done, and they invited us in to use the workshop, to use their hydraulic press to build our bank and coached us through it. So we went with them. We didn't actually price, we probably could have gotten them cheaper if we wanted to.
The one way to get them cheaper that some hobbyists have done is because there's about, I think every lithium battery that's being mass-produced right now is made in China from about 4 or 5 different factories over there, and each one's got a different chemistry, different set of cells. And then there's maybe about 20 companies targeting electrical vehicle hobbyists in the U.S., maybe 10 or 20 that import them in bulk and then mark them up a little bit and sell them. And then there's a couple companies that are then starting to package them into batteries. And some of them have been, I've actually called them on this, they've been a little deceptive, is that they have the flag at the bottom of their site and they say, made in the USA. All they're doing in the USA is wrapping the metal, the binding around it and putting a label on top. So it's I wish they were made in the USA. At the moment, they're not, and beware of any company that tries to make too much of a claim otherwise.
Usually says assembled in the USA.
Yes.
Some of them say made in the USA, but some of them are say assembled, and that is true. Just like at KitchenAid yesterday, they were very clear about that. They're assembling them in the USA, but the parts are coming from all over.
Some of the parts come from everywhere.
Yeah.
So there's I know of I think 1 or 2 companies that are starting to package them up into kits. One in particular is trying to sell them to RVers.
And they're trying to make them to be direct replacements for the popular sizes used in. So you could do a direct swap, knowing that people already have a dedicated amount of space in their battery cabinets.
Right. Smart batteries doing that.
Yeah, we've talked with Smart Battery.
And then the lithiumionbatteries.com is doing that, and there's and so the care and feeding of lithium batteries, the big things is you've got to be very careful not to overcharge the batteries. You have to be very, very careful not to get the battery below zero. You can theoretically use 100% of your capacity. You can take the battery from 100% down to zero. If you take it off the cliff, lithium's even worse than lead, have a potential of never coming back. And that make you very sad if that happened to your fancy batteries. So that's where a battery monitor system comes in. The company we got our cells from, part of what they do is they just take the cells from China, but they've designed their own battery monitoring system.
Before you get into that, can I ask you a question, Chris? Sean Welch here a year or so ago, I think it was, bought All-Note AGM.
Yep.
Champion. But you apparently have talked to him maybe down in...
He actually helped us design the system. So.
Okay. Now, if he were asked today, would he go to this?
He's carefully watching what we're doing because he's planning. They're shopping for a trawler right now to go full time on the water. They have told us that they're looking at. One of the reasons he was so willing to help us design our system is he's looking at that as pre-research for the potential for his boat. I don't know how his feeling would be if he had to replace his battery bank on the bus right now.
I think because his bus is designed, he doesn't want to have to redesign the electrical system, potentially change his inverters, and do anything else. he's kind of done with his bus. He had to get new batteries because they were dead, but he didn't want to have to change the design in any way.
Right. That's too much of a hypothetical question, and maybe if Sean's watching, I don't know if he's watching on the internet. He might be. Maybe he could chime in and let us know if he was designing his system from scratch, would he go this way?
This is actually the.
That's Sean's drawing.
Sean, when I was trying to figure out how to wire up the battery monitoring system and everything, Sean designed a circuit for us. Ended up not using it, but or I ended up doing a design of my own that was simpler. But yeah, Sean was very involved in our figuring this all out.
Yes, he spent a lot of time with us designing this.
Sean's amazing. The other catch, so don't overcharge your cells, don't undercharge, and then each individual cell. So there's 4 cells across to make a 12-volt bank. It would be 8 if it was a 24-volt bank. You want to keep the cells balanced. This applies to lead acid, but nobody really pays attention to this because it's not quite as much of an issue. But you want to have the cells having the same voltage. You don't want one cell to get over discharged, such that if you're draining the battery down, one cell drops off and then doesn't charge back. So the battery monitor has a little sensor across each cell that monitors the voltage on each cell, goes to the control box, and the control box, based on each individual cell as opposed to the whole battery, can pull the plug on the battery. And I've got a screen inside. I can actually see the voltage on each of the cells as well. When we were putting the battery together, they actually came unbalanced, and so I had to use a 12-volt load. I used a 12-volt light. Getting out of whack hardly at all anymore. These are still too new. I don't trust them. Nobody trusts them. You want to be able to just watch the cells just to see how they change over time. And then it's really good to have a programmable charger that has more than just the AGM gel lead mode, so that you can play around with finding the ideal charging voltage and try and tell your charger you don't need absorption time. You don't need to have an absorption voltage and so forth. That's part of why we went with a Victron inverter. There's a couple other reasons we went with the Victron inverter. But one, it's fully programmable. I can change any setting on the inverter and program it for how I want the batteries to be done. And then the other really great thing that Victron does is, like the old traces that aren't made anymore, is it can boost combined power from the battery with shore power. So we can be on a 15-amp plug, turn on the air conditioner, turn on the microwave, not blow a circuit. It'll combine power from the battery with the shore power and keep us going. It's an incredibly useful feature if you're ever trying to get by on a long umbilical extension.
Because we do a lot of driveway surfing with friends and family, so that really helps give us a lot more options and versatility. Remember, we're designing for versatility to go anywhere or do anything we want to do.
Yeah, the low Trace used to do it. That's why the old Trace inverters still have value on eBay, because they don't make them anymore. Xantrax bought them and shut it all down.
Yeah, Xantrax were bought out by Schneider about a year ago.
Yeah.
And they are making them, to the best of my knowledge.
Not that style of trace, not with the load sharing. Magnum has been promising they're going to bring that feature out within a year for the last 5 years, apparently. At the moment, the only 2 new inverters that have that are Victron and Mastervolt, which are 2 European companies that primarily target the marine space. So we had to find our inverter in a marine store. But it's a great inverter. The cost of the inverter, here's our prices of all the system. The cells and the battery bank was $3,100. The battery monitoring system for the Elite Power Solution, the one that monitors each individual cell, was $300. The inverter charger is also 120 amp charger, was a $2,000 list. We actually played.
I think it was like $1,800. We found it for $1,800. We basically pitched every marine company that was a vendor and said, give us a bid. And tell us what you'd sell it to us for.
And then the Victron control panel that lets us program the Victron and see the battery status by percentage.
And you're welcome after if you want to come in and see it. We're happy to show that off as well inside.
And then
all of our electronic stuff came out of the
yeah.
We don't. The RV industry always is counting.
Mm-hmm. And the marine industry tends to have a higher quality bar usually, particularly in the mainstream RV space.
A little more money.
Yeah. And and then the process, because they're selling these batteries. The company we went to is selling them primarily for people building electric cars. So batteries we got were 100 amp hour, 12 volt batteries. There are 4 cells packaged together with metal, and typically in an electric car you'll actually build a 130 volt or 144 volt bank of 100 amps. So you have really high voltage, not necessarily a high amperage across it. To build a house system, we had to take these batteries, disassemble them. I'll give you kind of a
right. So each one is about the size of a cereal box.
Yeah.
When you see those, when he's talking about a cell,
right.
Or
There's
the
20,
unit, it's hard to say.
There's 20 cells in here, so four across to give 12.8 volts, and then 5 to give the 500 amp hours. So 4 by 5. So we had to basically disassemble all these cells and then bolt them all together to make one. That's one battery. It's all bolted.
It wasn't difficult. It was just, I recommend a power screwdriver because you're doing a lot of screwing and unscrewing.
Uh-huh.
And it took us about 8 hours of screwing and unscrewing, and a hydraulic press, just learning how to.
The batteries, when they're tied together with metal bands to keep them from swelling, and so when you undo the metal bands, they swell out a little bit, and so once you put them back in how you want them in the configuration of 5 across, then you put a press on it to squish it down a little bit to get the band back over it to hold it tight in place. And yeah, because the batteries are packed in very thin plastic containers, so they swell, and the bands prevent that. So you'll see that if you stick your head inside. And yeah, that's about it.
Do you mount it in any configuration?
Yep.
No. It could be sideways. It could be any angle. I probably wouldn't recommend upside down, but there's actually no venting or anything else. They're not angle specific.
Right. If you have a specific spot or space that you're trying to fit them into, they're doing that. They actually have direct replacements for the popular sizes.
And then they take some of the
What's the physical size of the 12 volt battery?
What's that?
Does the physical size compare to a wet 12 volt battery?
The size, the density it's a much smaller battery, but if you want it to fit in the same kind of battery size box, there's a couple companies that are trying to package them together. The one that's been kind of the most aggressive marketing to RVers is I think Smart Battery.
We've talked with him.
To them. I'm very careful not to endorse them because they have changed their story and specs several times over the past year and a half. AM Solar, which is a company that does solar installations for RVs, was actually testing their batteries to resell them.
And ditched them.
And they were blogging their testing experiences, and the batteries fried a couple times. They had some major issues with them.
And they announced that they were abandoning the test
Right. project.
We've talked to them, and he's several times suggested that we should test one of his banks, and has not yet.
And he's like, I want to send you one. I want you to test it and write about it.
But you can't talk about any other lithium-ion source ever. It's like, no, I'm sorry, we're not. We're completely impartial. We have nothing to sell. We're not marketing for anybody. But we're more than happy to be someone's test case. Right. And show comparison, but we're not going to give priority to any company. I mean, even the company Elite that we went with, we love them, but we don't. I mean, we do endorse them because we thought they were awesome.
We had good service.
We had good service, but that's why we endorse them. We paid full price for our battery bank. They did not kind of say. They did give us wholesale pricing.
I think anybody who asks them, say, hey, what kind of deal can you give me? I want to buy 20 cells. We get the same deal.
We didn't get special treatment. We didn't ask for it from them.
So the Smart Battery guy, I've talked to him on the phone several times, and his goal, I really like his goal of making it really just drop in easy for the RV market. I have yet to run across. I keep asking him, can you point to anybody who's using your batteries yet?
Can you put us in touch with someone?
And he told me, Newell is testing my batteries. Newell is going to be bringing them out in the Newell coaches the next model year. I actually called up Newell, ended up talking to their head engineer, and he had issues and was sending all their batteries back and was postponing the project. So everybody I try and follow up with them, they've had issues. Right. I really like their goal. If they ever actually figure out whatever their issues were, it'll be great because it'll be just the drop-in, go-for-it thing. They're the ones I caught with the Made in America thing, and they're like, really, it's not. And they had things listed on their site that I found out that they didn't actually have in production yet. They were just and then they have a 10-year warranty. But
or 5-year warranty,
or 5-year. They kept changing their warranty terms almost at random, and there was no actual details of what that warranty meant.
These don't sound like people you really want to be business with.
If they ever figure it out, if they get their business
right, it would be very different if they could point us to someone who has had a positive experience, or if they want to send us a bank to test, or let us.
Like they may want to create that situation. I mean, it's just
yeah.
these are not honorable people that I want to do business with.
But look, you guys put it together.
Right.
You're not saying you're not surgeons, but you're not brain surgeons.
Right.
You know, and they're having so much trouble, you'd have to ask.
Well, I think a lot of the trouble is because they're trying to build the battery monitoring system smart into the battery to make it foolproof. And they went with some undersized components for that. So they're trying to make it foolproof, but somebody runs their microwave. That's just what happened to the AM Solar guys. They did a long test running their microwave, and the internal piece melted away, and the battery was dead, and then it's not user serviceable in that part. We accept that something strange might happen. I did all the wiring myself. I might
if something goes wrong, we have one person to blame.
It's dangerous to make things idiot-proof when it's still on the cutting edge, and I think that's the
yeah. We do not consider lithium-ion yet to be mainstream. It is definitely something for people that are wanting to be a bit on the cutting edge, are willing to play around with new stuff, and willing to go play around it a bit in the uncharted territory. It has been used in the marine market a lot more than it has in the RV market. I think we now know of maybe 15 or so people that have them in RVs and using them that have done similar self-builds that we're in touch with. And, we try to keep in touch with them and see how their experience is going. We think more and more are going to be, and we definitely think in 5 to 10 years it will be mainstream.
Right.
We do consider it cutting edge, and we do consider that if you're not willing to play a little bit in new territory, stick with the tried and true AGM.
Right.
You know of no converters that are experimenting with them today?
Actually,
Newell was.
Well, I believe Marathon has it as an option, because in which case, they're doing all custom. You're paying for it in that case. I don't know what they're charging for it, but I believe that they actually do have lithium as an option. Newell was backed out, and that's it. That's what I know.
Can you talk a little bit more about the charging
Okay, so right now I think I've got our set. This is one of the places where there's a bit of uncharted waters. There's no Elite Power doesn't have a set of specs of here's how you should charge it for a house bank, because all their customers are using electric vehicles which have very different charge up, charge down parameters. But in consultation with them and comparing notes with some other people, what I've settled on and seems to be working really well is I think I'm charging to the 14.4 volts, and then I can't tell our charger not to have an absorption phase. I just can tell it the minimum is an hour. Even though it's Victron, it's programmable, but it won't go to 0. It's got a 1 and counts up from there. So I've got it absorbing at 14.4 for an hour, and then floating at 13.6. So that way the batteries should be at no risk of getting overcharged. And there's no need for temperature compensation with these.
What do you use, Victronics or Victron?
It's Victron is the charger. Victron, Victron. And so that's I played around with different charges. The little battery monitors that mount under each cell also have a thing called a balancer on them, so that if the cell gets to a high its peak voltage of what is it on the cell, 4 volts across the cell. No, it's a little bit under, like 3.8 volts across the cell. It will start to put some of that extra current into a shunt, and you'll see green LEDs on them. That indicates that they're getting power. If the red LED comes on, that means it's shunting some of that power to try and hold the cell at that peak voltage, so that the cells can come into balance when you're bringing them up. But it's only a 0.5 amp worth of shunt, so you want to if you ever want to do a balancing charge, you bring them up very, very slowly with a very slow charge current. Again, I like the Victron. I can tell it's a 120 amp charger, but I can say use only 20 amps for charging. I can program how many amps I want to put into the charge side if I want to play around with balancing the batteries. Once I got them balanced, it's been about a year, and they seem to be staying really balanced. I'm overdue. I want to do a test of bringing them all the way down to zero again, just to see how much capacity, if anything's changed over a year.
That charger's built into the inverter, right?
Yeah, the charger's built into the inverter. And
So you charging these going down the road off the bus?
Off the bus alternator, yeah.
Straight.
And what do you use it next?
What's that bar?
Yeah, don't bend it.
For your regulator, are you just using the original double regulator?
I'm using the bus regulator, and then I have I've learned that I trust the inverter to not charge too high because it's programmable. I'm not sure I trust the bus alternator yet to go too high, so I've got...
I wouldn't.
Right, exactly. So I've got the EMS's contactor cutting off the wire to the alternator. So if any of the cells are fully charged and are hitting that top point, it disconnects the wire back to the alternator automatically.
And the EMS
is the battery, is what monitors each cell, and then basically if the cell's too low, it disconnects the battery from one side. If the cell's too high, it disconnects the alternator to what's being disconnected on that side.
And could you go through your inverter all the time though? Use the inverter and charger are the same unit.
Well, the charger takes 120 volts and makes 12 volts to charge. It can't regulate the 12 volts coming off the alternator. That's 12 volts, 12 volts.
Right. If you're running AGM batteries and you're charging them with a bus alternator, you need to have a dedicated
regulator.
Yeah. I mean, Campus Power made them. I don't know.
Yeah.
They're hard to find now. They're hard to find.
Well, I've got some. You will overcharge your batteries because you run long way.
Yep. Yeah, and I keep that as a I turn that on manually. I don't leave that on all the time too because I'm still.
But it's no big deal to add a voltage regulator. It's not expensive. It's damn sure worth it.
I would love to if you've got leads on where I can find one, particularly one that's programmable.
Does Ample Power still sell one?
I don't know. I haven't found that yet. I haven't looked into it.
You could also charge them with a 24-volt charging system, could you not?
Yes.
Well, our coach is all 12 volts. So the alternator is 12 volts, starter is 12 volts. So that's why we went with the 12-volt system. But if we had a 24-volt coach, we would have gone 24 volts.
If you charge them real fast, there's an economic curve.
Oh, you don't charge. You never charge a 12-volt battery at 24 volts. They're very different. You can charge at higher amperage, is what you're thinking. You can go to a higher and higher and higher amperage, but you still want to be charging at 12 volts. Or in the case of this, it'd be 14.2 volts. It'd be the charge voltage.
What do you float those at?
We float at 13.6.
13.2?
13.6. And you can do both show and tell crawl in here, and also I can show off the controller inside that shows off that.
Yeah. Is it a factory alternator or did you change it?
It's a factory alternator, so 220 amp Delco. Yeah.
50 DN, right?
Yeah, it's a 50 DN, and I've discovered that it's just right about break even running the air conditioner through the inverter.
We actually lose a little bit.
Depending on the driving conditions and the RPMs, we could either get to the end of the day and be the battery slightly higher charge or slightly lower charge if the air conditioner's been running the whole time.
How many watts is it?
How many watts is the inverter? It's 220 amps times 12, but that's 220 amps at full RPM.
No, it's your inverter.
Oh, the inverter is a 3,000 watt inverter.
24 volts.
So it'll run one air.
It'll run one air.
So do they self-discharge in time? You say you're always floating them.
They don't self-discharge much at all. Ideally, you wouldn't float them at all, but you want to power your 12-volt system. So there's no way to really isolate the battery, or that would be a complicated circuit to isolate the battery when you're plugged in on shore power and just bring it back in otherwise. So that's why I've got yeah, I settled on 13.6 seems to be a good, reasonable, doesn't age the battery, slow voltage.
How do they work in the cold weather?
The specs on cold, and I have to double check on the Elite site, is, if I remember right, they work very nicely discharging while below freezing, but you don't want to charge them while they're below freezing. And I know some people who have done lithiums who are paying more attention to being cold weather actually have a build into the battery case a heat blanket set to keep them at like minimum 34 degrees. Either that, or just be very careful not to start charging them until you've warmed up the bay, or have them in a utility bay with like where your water tanks would be and stuff, where you're trying to keep them above freezing as well.
What are they doing on electric vehicles, I wonder?
I think actually a lot of electric vehicles have the heat blanket built in, keep the battery at a minimum temperature.
Head for warmer climates.
Yeah, that's the main one.
Yeah. And or actually, well, particularly commercial electric cars have very smart charge controllers that would know that would be watching the temperature and say, okay, well, the car is below freezing right now. We're going to discharge. We're not going to charge until if we plug in the charge, we'll turn on the heat blanket first, get the battery warm, then start charging the battery.
Do they create heat? Does that battery create heat out of using for charging?
It creates very little heat. It has very low internal resistance, so that's why it doesn't waste a lot of power while charging it. The inverter gets hot, but the batteries themselves don't generate too much extra heat.
So there's no gassing?
There's no gassing. What's that?
Well, yeah, I just went by. I don't know if it's on. No, he just went by. I don't know if it's going in or out or not.
So what we'll do, give them, let's take time to, under the bay in the bus. Up at the lodge, we're warming up the leftover pulled pork and brisket and cheesy potatoes and rolls. So it's kind of an on-your-own lunch, but we got a lot of stuff to eat. Pie. Bring your own plate, but we'll do a lunch, and then we're going to have an afternoon session at 1:30. So not. By the way, too, those family motor coaching magazines I brought in here, those are kind of mine, so I don't know if anybody took any of them, but I need them back. They're to look at there.
Awesome. They're very cool.
Yeah, thank you for $465.
They are. Is it true that you knocked over a museum to get them?
No, I've had them.
He is the museum.
The 1:30 meeting's in the lodge.
Yeah, I'll be in the lodge. Fred's going to do it. Got Peter and our recent walk-in guest, Ed Todson from Pennsylvania, who got up at like 2 in the morning just to get here.
Oh, wow.
Right now.
Yeah. Well, old-fashioned cars. Won't go very fast.
As long as you got legal license plates on it, Ed, we're good.
Oh.
Okay, so that's kind of the plan, and we'll go from there.
Thank you.
All right, Internet viewers, thank you for joining us for our first ever youth streaming experience. We just downloaded the app to our iPad this morning to try to do this, and it seems like it worked pretty well. So maybe we'll do this again in the future. We thank you for joining us.